Can you see the screen?
Yes, sir.
Okay, so this was the circuit diagram as we had seen in the previous class. There was an AC supply, Vm sin omega t, 4 SCRs, T1, T2, T3, T4, and this is the armature circuit of the DC motor. The field circuit is not shown in this circuit diagram. Okay. If you really want speed control above as well as below the rated speed, then your field circuit also should have a rectifier, either half controlled or fully controlled. Okay, this is the armature terminal voltage and this is the armature current. Okay, these are the waveforms that we had seen. We are considering discontinuous conduction first. Discontinuous conduction happens when the armature current becomes zero before the next set of thyristors are turned on. Okay. So if beta is less than pi plus alpha, we are going to get discontinuous conduction. Okay. We had seen that when T1 and T2 are on, the armature voltage is equal to the supply voltage. When T3 and T4 are on, the armature voltage is equal to the negative of the supply voltage. And when all the four devices are off, the armature voltage is equal to the back EMF. Because we are not considering any source inductance, there is no possibility of all the four devices being on simultaneously. Okay. Okay. I told you about theta 1 and theta 2 also in the previous class. Okay, so as you can see, the armature voltage, I think this also we had discussed. This is not perfect DC. Okay? It has a DC component as well as a number of harmonics. And as I told you in the previous class, the harmonics can be filtered out. Okay? So that what passes to the load is the DC component only. Okay? How much is the DC component in this armature voltage? Anyone? How much? Can you hear me or not?
Yes, sir.
Yes, sir.
Yes, sir. So we have to find out the average voltage. That will be the.
Yes. The average output voltage is the DC component. Why is it so? Anyone has any idea why is it so? Why the average value is the DC value?
Sir, average value of AC is 0, sir.
Yes. So it has the DC component and AC components. All AC components, the average is 0. That is why if we can find out the average of this voltage over one cycle at least, then that average value is the DC component in the armature voltage. Correct? Now, how to find that average value? That average value can be found by using integration. I think you know this. Okay. Suppose we have any function f of t, f as a function of t, and let us say this is that function, and I want to find out the average of this function from t1 to t2. How do you find it? What is the average value of this function from t1 to t2? Yes.
Integration from T1 to T2 f of t dt.
Correct.
1 by pi.
Integral from t1 to t2 f of t dt. What is this integral t1 to t2 f of t dt?
So area under the curve.
Area
under the curve.
It is the area under the curve. And if you divide that area by this time period, t2 minus t1, then what you are getting is the average value of this function. Correct? Yes?
Yes, sir.
Yes, sir.
Yes, sir.
So similarly, the average value of this armature voltage can be found over a cycle by integrating. Identify one cycle of this armature voltage. From where to where is one cycle? Is it 0 to 2 pi? Or is it 0 to pi?
0 to pi.
Yes. Either you can take 0 to pi or you can take alpha to pi plus alpha. Which one is better? 0 to pi?
Alpha to pi plus alpha.
Alpha to pi plus alpha.
Why? Why not
Sir,
0 to pi?
so Vm sin omega t is same function from alpha to pi plus alpha.
Yes. If you take 0 to pi, then you will have 3 integrations. Right? One
Yes.
for Vm sin omega t, one for E, and one for minus Vm sin omega t. But if you take from alpha to pi plus alpha, you have only 2 integrations. One for Vm sin omega t and one for E. Okay? That is why we will take one cycle from alpha to pi plus alpha. Okay? Now, if you see, it will be integral from alpha to beta, Vm sin omega t d omega t, plus integral from beta to pi plus alpha, E d omega t. Everything divided by how much?
Pi.
Pi. Okay? So, there is a beta involved in the integration. And what is beta? Beta is the extinction angle. What does beta depend on?
Time constant
Sir,
L by
inductor
R.
value, sir.
L1.
Inductor resistance.
Beta depends on 3 things. What are those 3 things? The first is, of course, the value of the inductance. Okay? If the inductance is 0, then beta is equal to
0, sir.
If the inductance is 0, then beta is
Pi plus alpha. Pi, sir. It equal to sir theta 2, sir.
yes, it is theta 2. If inductance is 0, then beta is equal to theta 2. If this E is not present, then beta is equal to pi. Okay? If the back EMF is not present, then beta is equal to pi. Because back EMF is present, beta is equal to theta 2. Beta is not 0. Panag. Okay? And for continuous conduction, the limit is beta is equal to how much?
Pi plus alpha.
Pi plus alpha, sir.
Pi plus alpha. Okay, so beta is not 0. If inductance is 0, beta is theta 2 or beta is pi if there is no back EMF. And for continuous conduction, beta is equal to pi plus alpha. Okay, so beta first of all depends on the value of the inductance. Okay, beta will depend first of all on the value of inductance. As you increase the inductance, the value of beta goes on increasing. Correct? Yes or no?
Yes, sir.
Yes. Second, it depends on
back EMF.
okay, this is your omega t. I'm just redrawing it here. Okay, this is alpha. Somewhere here you have pi. This is b. No. And this is pi plus alpha. Okay. So if you go on increasing the inductance, the value of beta goes on increasing. The upper limit is of course pi plus alpha. What is the second factor on which beta depends?
Firing angle.
Yes, it depends on the firing angle. As you increase the firing angle, the value of beta goes on
Decrease.
increase or decrease.
Decrease.
Yes, as you go on increasing the firing angle, the value of beta goes on decreasing. For example, suppose this angle is pi by 2 and you are triggering here. How much do you expect beta to be? Can you get this type of waveform?
No, sir.
No.
Beta.
Basically, your inductor is a passive element. It is essentially a passive element. Okay? It is releasing energy, but it can release only as much energy as it can store. Okay? So as you go on increasing the value of alpha, you are decreasing the energy that the inductor can store, and hence the energy that it can release. So as you go on increasing alpha, the value of beta goes on decreasing. Is this clear, everyone?
Yes.
Yes, sir.
Yes.
That is why if line commutated inverter, how many of you have studied line commutated inverter? Okay, even if you have not studied line commutated inverter, in this case also continuous conduction is possible. Even if you remove E, continuous conduction is possible only if value of alpha is less than 90 degrees. And you cannot get continuous conduction if alpha is greater than 90. Okay. Achha. Chalo, what is the third thing on which beta depends? One was the inductance, second is the firing angle. What is the third? Somebody gave the answer. It depends upon the magnitude of IA. Okay? Or amplitude of the armature current. Higher the amplitude of armature current, greater will be the value of beta. And this amplitude of armature current will depend upon the back EMF. Somebody said back EMF, I think. So this magnitude of armature current will depend upon the back EMF as well as the resistance of the armature circuit. Okay? Okay, clear?
Sir.
Yes, sir.
Yes, yes.
Okay, so we see that beta is a highly complex parameter. Okay, that depends on a number of things. What is the relation for finding beta? What is the formula for beta? Beta is equal to how much? Beta is equal to, पढ़े थे फॉर्मूला कि नहीं पढ़े थे यूजी में?
नहीं सर.
नहीं पढ़े थे किसी ने? एनीवन?
Sir, 2 pi minus alpha.
2 pi minus
Alpha.
alpha? नहीं, that is not the formula for beta. Anyone else? Nobody? Subhajit? Suman?
No idea, sir.
Okay. Nobody has studied the formula for beta because there is no formula for beta. Okay? So, if there is no formula for beta, how do you find the value of beta? How do you find the value of beta? Because it has to be found. If you want to find the average value, you need the value of beta. Okay. So, how do you find beta? Does anyone know?
Sir, we can put the current, armature current equal to 0
Yes.
at that instant.
Yes. And what is the armature? What is the equation for armature current? That we will now derive. Okay.
Yes.
Okay. This armature current is because of two sources. One is this AC source and one is the DC source. Okay. In steady state, what is the component of armature current because of the AC source? How much is it? If there had been no thyristor, suppose, then how much would be the armature current because of the AC source? Okay, I'm applying the superposition principle here. Okay, I'm short circuiting the DC source. Then how much will be the current flowing because of the AC source? Yes. Okay, you forget about the thyristors, you forget about E. How much is the current then?
V by
V
R.
is divided by impedance of the circuit. That is RA plus omega LS.
क्या क्या फिर से बोलो.
Sir, V is divided by the impedance offered. That is RA plus omega LS.
RA plus omega LA.
XL sir, मतलब omega L.
So Vm sin omega t minus E by impedance.
Superposition theorem we are applying now. You forget about E now.
So Vm sin omega t by Z.
Yes. Okay, basically they teach this to you in first year. Okay, so the armature current has one component because of the AC supply, one steady state component because of the AC supply, that is Vm by Z sine omega t minus phi. Correct? Yes. What
Yes,
is
sir.
Z?
Yes, sir.
R plus
R plus
XL.
Under root of R square plus omega L.
omega L also.
That is under root of R square plus omega L whole square. What is phi?
Tan
Tan
inverse
inverse
omega
omega
L.
L.
Tan inverse omega L upon RA.
Tan inverse of omega LA upon RA. Okay, this is because this is the steady state component of armature current because of the AC supply. Now, once again, by superposition theorem, what is the steady state component of armature current because of the DC supply? How much is it? You forget about DC
E
supply
by
now?
R.
Yes, it
E by
is
RA.
E by RA, because in steady state, the inductor will behave like a short
Short circuit.
circuit to the DC supply. So what do I write here? Plus E by RA or minus E by RA?
Minus sir.
Yes.
Minus.
Minus, sir.
Also, there is a transient component involved here because of the SCRs. Okay? So both these components will have transient components also. Let us say that transient component is given by K1 e to the power minus t by tau. Okay? And what is the value of tau?
LA by RA.
LA by RA.
Yes, tau is equal to LA by RA. How many unknowns do you see in this equation? Do you know VM?
Yes, sir.
Yes, sir. It will
Just
be
only K1 and
Yeah, we are giving the supply, so we know the value of Vm. Do you know Z? Yes, it can be found out. You can find out the value of armature resistance and armature inductance. Omega is again the supply frequency, that also you know. Phi is again dependent on LA and RA, so phi also you know. Back EMF is also known. RA is also known. Tau is also known. Okay? So there is only one variable in this equation, that is t, and there is one unknown in this equation, that is k1. Okay? How to find the value of k1? How to find the value of k1?
Using initial condition.
Yes.
initial condition.
E equals to
By
0.
using kya? What equal to 0?
T.
T equal to 0.
T equals to 0.
Instead of t equal to 0, it will be much better if you go for okay. T is equal to 0 is not the correct initial condition here. Okay. Why? Because I have not drawn the full diagram here. If you see the full diagram above, correct? है ना? This current is there. At t equal to 0, armature current is not 0. So
Yes.
we cannot use t is equal to 0. We have to use, what do we have to use?
Equals to 0 at beta.
बीटा कैसे यूज करेंगे? फिर दो अननोन आ जाएंगे उसमें. We have to use that
Alpha
omega t is
by
equal
omega.
to alpha. IA is equal to 0. ठीक है? So this equation will become This equation will becomes 0 is equal to Vm by Z sine alpha minus phi minus E by Ra plus K1 e to the power T is alpha by omega. Correct?
Sir.
T is equal to
Yes,
alpha by
sir.
omega and tau is equal to La by Ra. Okay. So by using this equation, you can find the value of K1. Okay. And then substitute that value back in this equation. Okay. And then there are no unknowns in this equation. Okay. So that equation, I'm writing it down directly, okay, instead of deriving, because on this board, so the final equation is IA as a function of omega t is equal to Vm by Z bracket sine omega t minus phi minus sine alpha minus phi e to the power minus omega t minus alpha. Omega t minus alpha cot phi. Okay, this is one term minus E by Ra 1 minus e to the power minus omega t minus alpha into cot phi. Okay, this is the expression for armature current. Okay. Yes or no?
Yes, sir.
How many of you have seen this before in the class?
Synchronous.
Just a minute. So how many of you have seen this? Nobody? 1, 2, 3.
Yes, sir. Synchronous machine transient current equation.
Okay. But in power electronics, you have not seen.
Power.
Okay, ठीक है. चलो, तो ये किसका expression है? Whose expression is this? This is the expression for armature current. Which armature current? This armature current. Okay. Now, once we have the expression for the armature current, we can find the value of beta by substituting. In this, we can substitute at omega t is equal to beta Ia as a function of omega t is equal to 0. Okay. So if we substitute that, what you get is Vm by Z sine beta minus phi minus E by Ra plus E by Ra minus Vm by Z sine alpha minus phi e to the power minus beta minus alpha cot phi is equal to 0. Okay, this clear? How many unknowns do you see in this equation?
Everything.
Only beta is unknown.
Only beta. What do you call this type of equation? This is a, what do you call it? Is it an exponential equation or trigonometric equation, algebraic equation? क्या बोलते हैं इसको? When Priya is not in the class, this class is very quiet. Nobody says anything.
Sir, it is
Sir,
trial
myself,
solution.
Priyam Lotha present, sir. Priyam Lotha present, sir.
Why you are not saying anything today, Priya?
Sir, I'm present, sir.
What is this type of equation called?
Sir, it is a trial solution.
It's not a trial solution equation. There is no trial solution equation.
Say iterative solution. Iterative solutions.
मैं पूछ रहा हूँ equation कैसी है? What type of equation it is? You are telling me how to solve the equation. It is called a transcendental equation. ठीक है? Yes or no?
Yes.
Are you seeing this word for the first time?
Yes, sir. First time, sir.
Yes, sir.
Yes, sir. I have not heard this.
Very poor, very poor. सर्च करना आज, ठीक है? सर्च करके व्हाट्सएप में बताना मेरे को क्या होता है. What is transcendental equation? Go on Google, search it and tell me on WhatsApp what is transcendental equation. ठीक है? I want answer from every one of you.
Okay.
Not in the common WhatsApp group, separately. Okay?
Okay.
Okay, sir.
Okay. So how to solve transcendental equation? That you were telling me. Okay? This equation cannot be solved by normal methods because it is not a trigonometric equation, it is not an algebraic equation, it is not an exponential equation. Okay? So this equation has to be solved by using numerical methods. Okay? Now you must have learned some numerical solution techniques. Correct?
Yes, sir.
So yes.
Yes. But this equation, being a single equation, it does not justify using complicated solution techniques. Okay? So we go for the simplest solution method, and that is the
Trial and error method.
yes, trial and error method. Iterative solution by trial and error. Okay? So what do you do in trial and error? You go on substituting the value of beta in this equation. Okay? And whenever the left hand side becomes equal to 0, that is the answer for beta. Okay?
Yes.
You have to keep one thing in mind while solving this by trial and error. है There is a, what do you say, caution. क्या one mistake that most people do while solving this equation? What could that mistake be? What do you have to keep in mind while solving this equation? If you don't keep that in mind, you will never get the answer. What is it?
Sir, radian, angle, and
yes. Beta has to be
theta
in
angle.
radian. All angles in radian. Beta, alpha, phi. Okay? All of them have to be in radians. If you keep them in degrees, then this equation will not be solved. Okay? So I hope all of you know how to solve an equation by iterative method. Correct? You will go on substituting the value of beta. Suppose you are getting left hand side as positive all the time. Suddenly for some value of beta, you get left hand side as negative. Then beta lies between those two values. The one for which you got it positive and the one for which you got it negative. Okay? So then you again narrow the range. You keep on going narrowing the range until you reach the final answer. Okay? Where will you start from? Initial value क्या put करोगे? Beta equal to 0?
Pi, sir.
Yes, we start from around pi. Okay? Because beta is, you know that beta is most probably greater than pi. but less than pi plus alpha. ठीक है, greater than pi but less than pi plus alpha. ठीक है, once you have obtained the value of beta, then what is VA? Average armature voltage, or the DC component of armature voltage, will be equal to 1 upon T2 minus T1 integral from alpha to beta Vm sin omega t d omega t plus integral from beta to pi plus alpha
5 plus alpha.
e d omega t. ठीक है, so I'm not integrating this. It is a very simple integration. I think you know how to do this integration, correct?
Yes, sir.
ठीक है, so just like the armature voltage, the armature current also consists of DC component as well as AC components. Okay. Just like the armature voltage, the armature current also consists of DC component as well as AC component. Now the average torque is produced by the DC component only. The average torque is produced by the DC component only. The torque produced by the AC components, average value of those torques will be 0. Okay, am I clear?
Yes, sir.
So the expression for torque average torque will be still K multiplied by IA. It will not be K multiplied by small ia, it will be K multiplied by capital IA. And what is capital IA?
So average.
It is the average armature current. Okay. What is the average value? What is the average?
So here, sir, torque is proportional to IA. Why you have sir written, sir, torque is proportional to IA?
Because
this is a DC series motor.
This is a DC separately excited motor, not series motor.
Okay.
I know.
Okay.
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 K, you know what it is. What is K?
K means multiplication of K and IF. Field is constant. Means.
KE5. Okay, so we know 3 equations already. What are those 3 equations? First, torque is equal to KIA. Second, the back EMF E is equal to K multiplied by omega M. Third, VA is equal to E plus IARA. And we also know now that this is the value of VA. Correct? So if you substitute the value of VA, then from these 3 equations, what you get is, okay? Once again, I'm writing the direct answer. Okay? I have the derivation, but very difficult to write all this on this board. Okay? So I'm writing the direct answer. You can derive at home. You are PG students now anyway. So omega M is equal to E by K. That is equal to Vm cos alpha minus cos beta divided by K multiplied by beta minus alpha minus pi Ra divided by K square into beta minus alpha multiplied by T. Okay, this is the expression for speed in case of a separately excited DC motor controlled by using a single phase fully controlled rectifier. Okay, omega M is equal to Vm multiplied by cos alpha minus cos beta divided by K into beta minus alpha minus pi Ra upon K square beta minus alpha multiplied by T. Okay. Yes.
Yes, sir.
Do you guys write these things or not? Or you wait for me to upload it?